Differentiation is something that can definitely get pretty complex, but keeping things just simple for now, we could look at, say, some variable that is dependent on one other variable. Well, in that case, if we're looking at y of x equals 5 sine of x, if we wanted to see how y changes with x, that's pretty straightforward. dy dx would equal 5 cosine of x. Now, there are plenty of real-world examples where we have some variable or some function that is actually dependent on multiple independent variables. Therefore, if we were to look at how that original function, in this case z, changes, we're going to need to look at how it changes with respect to each independent variable separately. So, if we were interested in how z changes with respect to x, that would just be the partial derivative of z with respect to x. And to solve this, we're going to treat x as the only variable where y remains some constant. Therefore, we will get dz, or partial z over partial x, equals cosine of x plus cosine of y. Now, if we were interested in how z changes with respect to y, we would just leave x as a constant while solving for the derivative of y, where the partial derivative of z with respect to y would end up being x multiplied by negative sine of y. And while this is a pretty simple case, is a good building block for working on more complex situations of functions with multiple independent variables.